Hey guys, this is Yadi Kalsi once again. Today we are about to cover a very interesting topic, which is actually not a part of your certification process, but it is always better to know a little more. This topic will actually help you out in implementing and installing small networks in the offices as well as homes. These days, as you understand, the home networks also are becoming like office networks. There are more and more machines which are being onboarded onto the network. So we will try to actually cover that. I just picked up a topic like small networks are the big word because this is how the networks start. So let's go and pick up the topics. I'll try to write the agenda today for the video. We are going to cover networks. When we say networks, we will categorize them as physical first, physical networks, NWs, and logical networks. How to build networks basically. We will cover certain hardware which you might actually hear in the field. They will call it switches. Previously they were called hubs. There is a difference between switches and a hub, and what I'm trying to do here today is we will not actually go into too much of the technical detail of the subject, because in itself, like if you go about switches and hubs, this itself becomes like an hour of a video. So I don't want to go into that. I will tell them what is the purpose of a switch in a network, and we will actually move forward from there. We are going to cover what are routers. Sometimes you may hear people calling it gateways as well. And then we will talk about some software services which are called DHCP and DNS. What they actually stand for. Here in that we will talk about Ethernet networks as well as Wi-Fi networks. These are the two major networks you will actually deal with in this section. And we'll talk a little bit about the OSI architecture layer. It's called Open System Interconnect Layer, and we will go from there. So let's cover the first OSI layer, why this is important, and how it actually pertains to the networks. So in order to cover the OSI layer, the easiest way to understand is who developed it, why they developed it. So there's like group of people got together in order to standardize something on the network, and they called it Open System Interconnect Layer. There are total 7 layers they talk about in the network, and we will only cover 2 of the layers. So we have 1, 2, so there are 7 layers. We'll go from south to the north. The very first layer is actually called the physical network, physical connections. Then we call it data link layer. So we call it physical layer. Then the third layer is called the network layer. Fourth layer is called transport layer. Then we call session layer, presentation layer, and application layer. So when we talk about the networks, multiple layers will be involved, but for sure these layers are actually definitely involved. But today we are actually only going to talk about these 3 layers: physical, data link, and network. So these 2 layers will talk as one, and this layer will talk as one. If you remember the previous screen just now, we talked about networks, where we are going to talk about physical networks, and we are going to talk about logical networks. So when we call it logical networks, we are talking about the logic behind the networks, and we are going to talk about these 2 layers. Don't get carried away with too much of this information, but as you actually grow in your career, you will understand why these things are important, why the physical connectivity, why the logical connectivity, how the transport of the information actually happens, what are sessions, how the application is presenting itself, and the application layer like Microsoft Word or any specific industry specific applications, how they actually work, right? So the idea is here, just imagine that 2 computers are talking to each other. through a software, some software data transfer is actually happening, and somehow they are connected physically. So you can imagine that there are 7 layers in this computer and 7 layers are there in this computer as well. So if the information has to go from this computer to that computer, which is computer 1 to the computer 2, the layer actually goes from north to the south here and then south to the north. For now, just understand this piece. So let's talk about the physical networks, how the physical networks are actually built in the homes. So what is required when you build up a computer network, or what exactly is a network, right? So when you connect multiple devices together, it's called a network in a very simple layman's term. So just imagine that there is a computer, right? One computer you actually bought from some of the mega stores. You ordered it on some online store and so on and so forth. This is computer 1 and this is computer 2, and you want to actually connect these computers for various things. You want to transfer the data files, you want to do something with it, right? So you have some video files here, some photos you want to transfer out to the computer 2 and vice versa. So what is the first requirement of these two computers talking to each other? So we'll always talk about the physical layer and the logical layer, right? So first the physical connection has to happen. So how the physical connection actually happens? For the physical connection, what we need some sort of port here, or some sort of port here, probably a similar type of port, and some sort of wiring which actually goes between these two ports. We'll call P1 and we'll call it P2, computer 1 port 1, computer 2 port 2, some sort of cabling, right? So when we talk about these new technologies in the home or the office networks, there are two technologies we are talking about: Ethernet networks and Wi-Fi networks. So Wi-Fi is also a type of physical network first. So the physical connection happens, but it is not over the wires. It is over a wireless environment. So let's talk about the Ethernet connection. What is required in the Ethernet connection? We can dig deep into it, but for this video, we are just going to cover like probably, I think 5,000-6,000 feet of a view. So in the Ethernet network, we need some sort of Ethernet port, right? So let's call it, if you go in the back of the computer, most of the computers actually come with an Ethernet port. In the computer 1, we will need Ethernet port. Here also we will need Ethernet port, right? So this is the Ethernet port, this is the Ethernet port. So then we need a cable, some sort of Ethernet cable with a port here and a port here. So what happens is, this is actually a female port, this is actually a female port, this is actually a male port, and this is actually a male port. If you guys actually go back into the videos which I have created previously, we talk about Ethernet networks, we talk about the cabling, Cat5e cabling, Cat6 cabling, and a couple of other cabling types. And also we talk about RJ45 jacks, right? So this is nothing but a RJ45 jack in a male version, and this is RJ45 jack in a male version. This is RJ45 female jack, and this is RJ female jack. So this jack goes into this jack goes into this, right? So there is a physical connectivity which we have already done, which is the first thing we have to achieve. Then there is a logical connectivity. Logical connectivity comes by actually addressing this computer. This is how it basically works. Why is it like that? By virtue of the design, basically. So there is certain addresses we actually give it to them. So just for the sake of simplicity, first we'll cover the IP addressing topics in the coming minutes. But just for the sake of this screenshot, we will say that there is called address 1, which is called A1, and we will call it A2, right? So in a very layman's term, we will say, hey, send the file A1, send the file to A2, and we'll say A2, send the file to A1. So now imagine that there was a third computer in place. How you are going to go back to the physical connectivity, how you are going to do the physical connectivity. Some of you might think, hey, it should be easy. There is an Ethernet port here, we will run a cable, do something here. But there is nothing, this is a jack. So there is no jack which can actually adapt these kind of connections, right? Two of the RJ45 jacks into it. What if there is another computer? What if there is another computer? What if there is another computer? So how this physical connectivity will be done and how the addressing will be done, we'll cover in the next screenshot. So I am actually, why I am giving you this problem is, we want to talk about a certain hardware. If you go back, you can see it's called the switches, right? So the switches will actually help us to connect the physical networks together. So what is the function of a switch, right? As the name signifies, it does some sort of switching, right? So just for a very in a rudimentary language, we can say it switches the connection between the computers. So switches does what? It switches the connection between the computers. How it does? So now imagine, and we are still building a home network. There is a computer 1, computer 2, computer 3, computer 4. And we have to make it complicated for you guys to actually understand what is required in order to do that, right? So then we go to the market and we say, hey, can you buy like a 5-port of a switch? So we basically go get a 5-port of a switch. We will say 5-port switch. If you go to the market these days, they might be marked as 10/100/1000/1000. So what it means is you might not find 10, but if it is there, it is okay. So this actually tells you the capacity of the switch. So most of the time you should actually go for 1000 Mbps or gigabits, GBs, right? So look for this one. They are cheap, cheap per piece. So you can definitely go for a higher speed. So basically, what happens is, so I'm going to buy a switch, a 5-port switch, which can actually 5-port means there are 5 connections. 1 connection, 2 connection, 3 connection, 4 connection, 5 connection. If you look at the switches, these are female connections, female RJ45s, right? So 1000 stands for the communication. So it is capable of delivering communication between the devices at 1000 Mbps speed. That's what it means. So higher the speed, the better it is, right? So let's talk about the switches helping out the physical connectivity, right? Computer 1, computer 2, computer 3, computer 4. Now we already have a female jack here, female jack, female jack, female jack, right? So what will happen is, all we need to do is take a cable, which is called a patch cord. Go to the previous video and look at it. A patch cord with a RJ45 jack on both of the sides, which are the male jacks, right? Now you run the cable from here to here, from here to here, from here to here, from here to here. So there are, how many patch cords are needed? There are 4 patch cords which are needed. What is required? So if you try to create a bill of material, so you will need 1 switch, a 5-port switch, and what you will need? You will need 4 patch cords. So this is how the physical connectivity will be done within the home. We are not talking about the internet so far. So if you can ask, hey, if there are multiple computers, if there are hundreds and hundreds of computers, hundreds and thousands of computers, how would you go about it? Yes. So what you do is basically you keep adding the switches to something called, in the technical term, we call it a switch stack, right? Switching stack. So we can talk about, let's talk about 2 or 3 different scenarios where you can get more comfortable with how to use switches in a home network and in a bigger network, right? So switches have a limitations too. From the physical port connectivity, there are limitations. I think from the home networks, you will hear, though the enterprise version actually offers something different, but the switches will be 48 port. I'm just talking about what you will hear in the market, 48 port switch. So it means we are actually limited by the capacity of this 48 port. So does it mean that we can only connect 48 devices in a network? No, the answer is obviously no. So there is a computer, there is another computer, and let's assume that there is, just for the sake of example, there are total 80 computers which you need to connect. How will you connect 80 computers in a 48 port? So what is going to happen is, I will go to the market, I will go buy 2 switches. 48 times 2, right? 8 to the 16, 4 to the 8 and 1, 9. Total 96 ports are available to me. I need total 80 ports. So I will be left with how many ports? I will be left with 16 extra ports there, which is okay. So you basically plan for the expansion of the networks as well. So we buy 2 switches and somehow we actually connect both of the switches together. This is called backplane connectivity could happen, stacking could happen. So there are multiple ways of actually connecting the switches as well. The simplest way is to use, there are 2 called uplink. You will read this, uplink ports. It means specifically that in order to connect 2 switches together or uplink this network to somewhere else, right? So you can use these uplink ports in order to actually connect both of the switches. So now all you need to do in the same diagram is just take the computers and drop the patch cords if you are using the standard architecture of structured cabling system, you guys should know by this time that there is a patch panel. You will terminate the cables here. So once you terminate the cable, what we're talking about is we will be dropping the switches here, two of the switches, switch 1 and switch 2, and we'll be putting the patch cord from here into these switches in order to create this network, right? So the physical connectivity will be done. So now the question is, if you go to an office space, let's assume that probably 3,000, 4,000 square feet of office space, and there are 100 computers, not all of the computers will be at one place. So the computers are at a different place. And now also we are limited by this 100 meter of a logic between the ports. So we cannot transmit any more than 100 meters. So it means from here to here, it cannot be more than 100 meters, else the connectivity would not happen. So now it cannot be ideal case scenario every time, right? So you guys need to actually put some thinking into it when you go into the market in order to create probably like an architect or design networks using the switches. And we are talking about the physical connectivity of it, right? So assume that there is a room, there is another room, and there is another room, right? Room 1, room 2, room 3, and they're far away from each other. Could be like 200 meters from each other, right? 200 meters. And don't dig too much of details into the metering of it. I'm just trying to say that these are like very far away, right? And within this space, it's less than 100 meters, less than 100 meters, less than 100 meters, right? So what you can do is you can pick up room 1 or room 2, as a central connectivity point for the switch. For this, you will have a separate switch. For this, you will have a separate switch. You will have all the computers in this room will be connected to this guy. All of the computers on this room will be connected to this guy, the way I actually explained in the previous video. And then you can have one more switch where all of these switches actually connect, right? So it's a switch to switch connection. So this is a possible connectivity. Then you can add actually a number. You can have like, there could be another connectivities. So you are not limited by, you are just limited by your thought. That's what I would like to say. So what I mean by that is you have a computer, you can put a switch here, then another switch here, then another switch here, then a computer, or then something else, right? You can have one more switch here. You connect the switch like this. You have one more switch. You can connect it like this, and then go out to the something called the internet, which brings us to the next topic of how to connect these computers to the internet. And we are still talking about the physical connectivity of it. So now we'll go back to a small example. So we have a house here where you have different rooms, and you have computers in different rooms. So somehow you figure it out that there is a switch which is needed in order to connect these computers. You will run these wires directly home runs into the switch, main switch, and then the requirement is this: the homeowner is telling you to connect all of your network to the internet, which is very, very common ask these days. So what is required? So when you go into the market or you talk to your colleagues or associates, they keep talking about something called router. Hey, go buy a router. Hey, go buy a router. So what exactly is a router? So router is, I would like to actually explain what router does basically. So router is a kind of like a security guard in a factory complex or a manufacturing unit. So imagine that this is a factory or a manufacturing unit or a big complex, a big home or whatnot, and you have like only one main gate to get out of this location, right? So anything which goes into this and comes out of this actually goes through something called a gatekeeper. What is called? Gatekeeper. This will actually help you understand other technologies also, why we talk about firewalls. So when we cover more topics, in more details, we'll talk about those things. But for now, just for the sake of simplicity, just remember that is the gatekeeper, also called the gateway, and also called the router. Most of the time we'll call it a router. And what a router does, there is a technical significance why we actually call it a router, but we are talking about the physical connectivity so far. So some connection will happen between the switch and the router, this connection, and then from the router it actually goes to, we'll represent this as the internet, goes to the cloud. So if you guys remember, you need to get a connection here from the ISP. So there will be a ISP modem or ISP router itself, which will be placed in your home, and then from here it actually goes to the ISP cloud, which means indirectly it goes to the internet, right? So this is the physical connectivity of how this connectivity happens. So we need couple of patch cards, again, couple of patch cards, switch, router. This will be provided by the ISP itself, internet service provider. This you might need to buy. Sometimes this gateway might also, or this router might also work. Sometimes you might not need to buy a switch as well. If you have less number of computers, and I will tell you why. Let's talk something about very specific, the routers. There are multiple models which are available in the market online. Netgear, Cisco, Linksys, there are a lot of them actually, the Buffalo, there are a lot of them in the market. Some actually come with Wi-Fi, some actually are very plain vanilla routers. So if you look at the router, all of the routers actually do the same thing. They connect two different networks. That's why they are called routers. So in a router, you will see something called an internet port. They have actually numbed it down, internet port, which is actually a WAN port, wide area network port. And you might have couple of LAN ports also. Most of the time they're on the same side. In the same side, then you have a power, you provide a power to this guy. This is a WAN port and this is the LAN port, local area network port, right? So what you do is, you bring your computers, connect each port to this guy, and then from here, you connect the internet cable or other router which is provided by your service provider, which actually takes you to the internet. So this is the physical connectivity of the gateway. Now once you are done with the physical connectivity of the gateway, we talked about there is a logical connectivity as well, and which is little complex to understand. But before we go there, I would like to actually explain you. So pretty much we have covered now the physical connectivity on the wired networks. Let's talk a little bit about how this wireless physical connectivity will happen as well, because these days Wi-Fi, this term is being used a lot. So how to build up a Wi-Fi or a wireless network using the same design principles. The gateways are required and everything else would be required as well. So in the very first example, I'll just go over quickly, going back to the very basics. We have two computers, computer 1 and computer 2. In the wired network, in the Ethernet wired network, what we did is we have used Ethernet ports here and a patch card which actually goes from here to here. But what will happen in the wired network, wireless network is there will be something from here and something here which will transmit the information over wireless, and this will actually receive the information over the wireless and vice versa. So there is a transmission TX and a receive, and here there is a receive and a transmit. Previously, if you go like almost like 12-13 years back from now, it's 2017 May. But if you go a little bit back, there used to be cards, PCI cards, which used to come with Wi-Fi transmitters, or they were called like Wi-Fi network cards. That way we would have that is a very classic example of what I have actually shown. But now the things have changed definitely 12-13 years from now. So you will be listening more about Wi-Fi routers or access points. In order to keep it simple, because we are not covering, again, this Wi-Fi in itself is a very big topic, but we will talk about routers with Wi-Fi capability, right? So here in my previous screenshot, we were using one router and we had computers here, right? and we were actually placing a switch here. We will not place the switch because the switch will be not required. The switch in the previous case actually provided us the physical layer of the connectivity between n number of computers. If there were 5 computers, we need 5 plus 1 or 5 plus 2 depending on the depending on how big you expanded network you want in the future. So we need 5 port of a switch or 10 port of a switch, or 5 or 8 or 16 or 12 or 24 or 48, what kind of switch was decided at that moment. Here in case we have a Wi-Fi router, and the Wi-Fi router is connected to the ISP cable modem or ISP gateway, and it actually takes you to the internet, right? So I will represent the router like this later on, but just take it as it is right now. So basically the Wi-Fi router provides the wire